Hello everyone, welcome to my channel. In my previous video, I have discussed about first come first served with non-preemptive scheduling. This is first come first served with non-preemptive scheduling, but here arrival time is given. So whenever arrival time is given, we have to follow a different method to solve this first come first served scheduling. So in my previous video, I have discussed about waiting time and turnaround time, and all. Just you can go through that. And now we'll see first come first served when arrival time is given, how the scheduling decisions takes place. Now here if you observe this, we have 5 different processes in the system in the ready queue, and at time interval 0 we had only one process. See the burst times here, guys. So here for P2 the burst time given is 1 millisecond. So at time interval 0, we had only one process, that is P2. P2 has arrived first into the ready queue. So we try to represent it in the form of a Gantt chart. So at time interval 0, the first process available was P2. So now P2 executes for 1 millisecond. So P2 completes its execution because its burst time is 1 millisecond. So at the interval 1, no process has arrived into the ready queue. So see the arrival time at the interval 1, no process has arrived. But at interval 2 now, when the time was 2, at time interval 2, we can see that there are two processes has arrived. That is P1 and P3. Two processes has been arrived. And these, when at time interval 2, when these two has arrived, see what is their burst time. P1 is having 2 and P3 is having 3. But now both has arrived at the same interval 2. Now which one to take now? So always consider which is the first process in this list. We have to follow this sequence now. Since both the process has arrived at a time interval 2, which one to take now? Either P1 or P3. We should take while solving P1 only because it is the first one in the sequence to break this type, since they both arrived at the same interval. So here the CPU will be given for P1. So at time interval 2, none of the processes was there. Okay, so at this time nobody was there. So after 2 who has arrived, P1 and P3, the chance was given for P1 to execute. Okay, since it is first come first served, it will be holding the CPU till its complete execution. It will not leave the CPU till its complete execution. Okay, P1 will execute now. So at the next interval, third interval, P4 has arrived, but still P1 only will continue the execution because it is first come first served. And next is P1's burst time is 2 milliseconds, so it will keep the CPU till its complete execution. At 4th millisecond, the new process P5 has arrived, but before P5, who has arrived? P3 has been arrived. So at the third interval, P4 has arrived, and at the fourth interval, P5 has arrived. But still, P1 will continue its execution, and later the control will be given for P3 because it has arrived before P3 and P4. So now the control will be given for whom? It is P3. So at the time interval 3 only, 4 has entered P4, and lastly at time interval 4, P5 has arrived. So P3 now will enter, P3 will get the CPU. So P3 will be holding the CPU till its complete execution, that is for 3 milliseconds. So that is 7. So by this time all the processes arrived. So no new processes. We have again P4 and P5. So among these two, who has arrived first? P4. So the next process to complete is P4. So next P4 will be holding the CPU. It needs 5 milliseconds. So the time needed to complete its execution is 5 milliseconds. So it will be holding the CPU till its complete execution. So 7 plus 5, 12. So P4 also completed now. The last process in the queue is P5. Now P5's burst time is 4. So 12 plus 4, 16. Okay, now we wrote the Gantt chart for this problem, Gantt chart represents what? It represents the processes and their burst time. Okay. So now from this, again we should calculate now what is the average waiting time and average turnaround time of all these processes. To calculate that, first we find what is the completion time of each process. So completion time, just see the Gantt chart. What is the completion time for P1? You should take the right hand side. Completion time is 4 for P1. Completion time for P2 is 1. Completion time for P3 is 7. Completion time for P4 is 12. For P5, completion time is 16. Okay guys, so we wrote the completion time. Next we should find what is the turnaround time of these processes. Turnaround time means what? The time from a submission of a process till its complete execution. The time spent by the process waiting in the queue and plus the execution time. So that is called as the turnaround time. So turnaround time for the process P1. Here completion time is what? 4. But when it has arrived into the queue after 2 milliseconds. So the turnaround time for the process P1 is what? 4 minus 2. So turnaround time is equal to completion time minus arrival time. Here arrival time is given. Okay. So the turnaround time is what? 4 minus 2 arrival time for process P1. 4 minus 2, that is 2. Then for process P2, what is the turnaround time? Completion time minus arrival time. 1 minus 0, that is 1. Here completion time, turnaround time for P3, 7 minus 2, 5. For P4, 12 minus 3, so that is 9. And for P5, 16 minus 4, so it is 12. So now we calculated the turnaround times. Next is we should calculate the waiting time. So what is the waiting time of each of the process? So guys, you always remember waiting time is equal to what now? So waiting time is equal to turnaround time. Okay. Turnaround time minus burst time. So this is the formula for the waiting time. Waiting time is equal to what? Turnaround time minus the burst time. So what is the waiting time for P1? For P1, waiting time is equal to turnaround time is what? 2. 2 minus, what is 2 minus its burst time. That is 2 minus 2 is what? 0. So it has not waited at all. When it entered, directly it got the CPU. See, at time interval 2 it has entered. It did not wait at all. Suddenly it got the CPU and it executed. So here also we are getting the same thing. Turnaround time minus the arrival time. 2 minus 2, it is 0. Then what is the turnaround time for P2? 1 minus its arrival time, 0. 1 minus 0 is what? 1. So here where the waiting time for the process P2. So here for the process P2, what is the waiting time? That is turnaround time minus the burst time. So what is its burst time now here for P2? That is 1 minus 1. So 1 minus 1, it is 0. Then what is the waiting time for P3? That is waiting time minus the burst time. 5 minus 3, that is 2. And for P4, 9 minus 4. 9 minus 4, that is waiting turnaround time minus the burst time. Turnaround time minus the burst time. Then for 12, 12 minus 4, it is 8. So this is the waiting time. So how do we calculate the waiting time of each process? Turnaround time minus burst time. Turnaround time is 2, 2 minus 2, 0. 1 minus 1, 0. 5 minus 3, 2. 9 minus 5, 4. 16 minus 4, 8. Okay guys, one more thing they may ask in the exam. Find the first response time. So I am adding one more column. Response time means when the CPU started responding for the first time for a process. What is the first response time given by a process by the CPU to a process is called as response time. Sometimes they may ask you to find what is the response time. So how do we calculate the response time? Response time is equal to, take the response time here minus the arrival time. We should take the first time when the CPU is responding to that process, that is first time response time minus the arrival time for the process. So for P2, if you observe here, when the CPU started responding for it, that is response time. If you see, you should take the left hand side. 0 minus 0 for P2 I am telling now. We start from P1. So for P1 the response time given here is what? 2. So here 2 minus 0, the response time we should calculate. So here for P1 the response time is what? 2 minus 2. Okay, 2 minus 2 means it is 0. Okay, response time, first time when it started responding minus the arrival time. For P2 here it is 0. 0 minus its arrival time is 0. Right? 0. Then for P3 4. 4 minus its arrival time 2. 4 minus 2 is 2. And for P4 it is 7. 7 minus 3 is 4. First responding, when it started responding for the first time. Then for P5 12. 12 minus 4 is 8. Okay guys, so this is the first response time given by the CPU for the process. If you observe this, the waiting time and the response time remain same here for first come first served scheduling. Okay guys, first come first served preemptive scheduling. This is what? Preemptive scheduling, whenever the arrival time is given. But first come for the SCFS is what? Non-preemptive scheduling algorithm. When do we speak about preemption here? Whenever the arrival time is given, we speak about the preemption here. Then what is the average turnaround time for this? Average turnaround time. Average turnaround time is equal to what? Add now 2 plus 1 plus 5 plus 9 plus 12 divided by 5. So you will get around 5.8 as the answer. And what is the average waiting time? Average waiting time, that is 2 plus 4, 6, 6 plus 8, that is 24. 24 divided by 5. So you will get around 24 divided by 5. So it might be around 2.8. So calculate the average, the total waiting time divided by the number of processes. Hope you understood this. Please don't forget to subscribe, like, share and comment. Thank you.